Hello guys, today we'll be studying about how to navigate around the planet Earth. So basically we are studying a topic in general navigation or navigation. So the topic that we are gonna study today is about latitude and longitude. Since childhood, we were always confused, or maybe sometimes confused, about what is latitude and what is longitude. So, these terms always in a geography lessons puzzled us as kids. Like, why do we divide Earth? Why do we do all this? So, what is the purpose of it? But now, as we are becoming pilots, so we need to navigate on the planet Earth. Let's draw our planet Earth over here, a small circular representation of the Earth. So, if we draw our planet Earth, I'll write it as Earth. And suppose we have to go from place A to place B, let's say, from place A to place B on Earth. So we need to exactly program our flight computers, or maybe program our systems, or maybe draw something so as to follow a route or something from one place to another place on Earth. So because of that, we need some system. So if suppose the Earth was flat, let's say if the Earth was as flat as a piece of paper, let's say if we could draw a map on a flat piece of paper, if suppose Earth was flat in 2 dimensions, we all know that the Earth is spheroid in 3 dimensions, but let's say if the Earth was flat in 2 dimensions only, then to go from point A to point B, we would still need some of the measurements. So to do this, we would represent the point A and point B, let's say on a graph. Let's say for we are drawing a graph here, and this is the x-axis of the graph and this is the y-axis of the graph. So let's draw a graph over here representing things on x-axis and y-axis is also called as the Cartesian coordinate system. So let's number them 1, 2, 3, 4 and 1, 2, 3 over here. So let's say if the Earth was a flat piece of paper which was in 2D, so these points A and B would be represented over here as A and B, and representing them on x-axis and y-axis, we could have represented them as, let's say if we draw imaginary lines from here to here, so we would write B as, first we write the x-axis, then we write the y-axis, so B would become 4 and 2 on the Cartesian coordinate system, and A would be 1 and 3. So that would be the case if Earth was a flat piece of paper, or like a flat piece of paper. But as we know, the Earth is spherical, so we can't represent it on a piece of paper like this. So we have to deal with something else. Let's see what it is. Let's draw the Earth again, or try to draw a circle to represent a sphere. Now we know that the Earth is divided between north and south by the equator, and we also know that the Earth is divided by a meridian from north and south, which we know as the prime meridian. This we have all learned in our basic classes. So now, to represent two different points, let's say point A and B on a spherical earth, using something from a sphere, we take the basic reference of the equator and we take a perpendicular line, which is basically a y-axis on a sphere, and we measure the, suppose a point is here from where we want to navigate, and we measure the angle from the equator to that point on which we say it as, let's say this point was over here and it is about at 45 degrees. So this point measured from the equator towards the north would fall on 45 degrees and would be written as 45 north. So this will mean that this is the basic definition of a latitude. So its latitude is 45 degrees north. Let's say if a point was over here and we draw an imaginary angle to it. So basically defining latitude is the imaginary angle measured at the center of the earth from the equator to the position on the earth, either north or south of the equator. So this would approximately become about 80 degrees north, measuring from the equator upside. So if there was a point over here, let's say, so if we measure the same from the equator clockwise, this would approximately become 60 south. So these measurements of angle from the equator towards the north and the pole will definitely become 90 degrees north, and this south pole would have become 90 degrees south. So the latitudes can go from 0 degree or the equator to 90 degree north and 90 degrees south, and they can be anywhere represented on this. This is one of the coordinates to represent on the sphere, which is known as latitude. Now we have to also define, if suppose a point is there on earth, only one of the coordinates like 45 degrees could be anywhere. Let's assume a line like this. 45 degrees could be here, it could be here, it could be here, it could be here, it could be here. So this will become a parallel of latitude 45 degree. But this line would also be represented like this. So anything, any location on any part of this line, if we assume that the earth is a sphere, so that would mean 45 degrees in latitude. And that would be ambiguous. We would not be able to define a precise location just using 45 north. This 45 is also written as 4500, 45 degrees and 0 minutes. So as to be more precise on which part of this imaginary parallel of latitude do we find our location, we have to define another angle, basically known as the longitude. So now we will define the angle which is called the longitude. So now we have drawn the earth over here. There is a vertical meridian which passes through a place called Greenwich in London. I am representing by G. So it is also called the prime meridian or Greenwich meridian. I'll write it here. So this Greenwich meridian, as the equator was given 0 degrees on the latitude, This Greenwich meridian is given a term of 0 degrees on the longitude. So if we assume the equator passes somewhere here, and this Greenwich meridian north-south vertical line is given as 0 degrees reference mark or the datum for measuring the longitude angle. Now, for measuring the longitudes, if suppose a position is over here, let's say here, towards the east or the right side of Greenwich meridian is supposed to be east, and towards the left side of Greenwich meridian is supposed to be west. So this is the datum from which east or west coordinates are defined. Similarly, as we defined north and south depending on 0 degree for the equator. So now, so as to measure this angle from here to here, we have to draw Earth like this. Let's assume that we are looking at the Earth from the top or from one of the poles. And let's assume that the Greenwich is over here, or 0 degree is here, and the opposite end of the prime meridian, also known as the anti-meridian, this is the prime meridian, this is the anti-meridian, is on the opposite side. So if the same representation of the spot over here, we look from the north pole. So this is, we are looking from above the Earth. The Greenwich meridian would be over here, which passes through London. So if this point is represented here, let's say over here, so we take the angle from the Greenwich meridian towards this side or the right side, which we call as east. So this angle is measured like this, and this becomes our longitudes. Let's imagine this angle to be 45 degrees. So this will be written as 04500 east. Suppose a point was over here towards the west of the prime meridian or Greenwich meridian. So we now need to measure this angle. So that would be represented over here in the view from the top or the north pole, and this angle would become like this. Let's say it is about 60 degrees measured from here. I'm just assuming. So it will become 06000. The first three parts are the degrees and the last two parts are the minutes. Same over here. So this would be represented as east 04500, and this would be represented as west 06000. So similarly, in the latitude, the north would be represented as 9000 north, and this is a 4-letter representation, but this is a 5-letter representation in which total degrees measured from the meridian to the anti-meridian is about 180 degrees. So the anti-meridian would be called as 18000. So this would be 0 and this would be 180. Towards the right side would be east meridians. Towards the left side of the prime meridian or the Greenwich meridian is the west meridian. And that is how we define the longitude. So basically the longitude is the angle between the Greenwich meridian to the east or to the west of a particular point, which is measured along the vertical axis of the Earth, and when seeing from the northern hemisphere, this gives us the longitude of a position. So as to define a point on Earth, first we write the latitude of that point. Let's say north 000, and then east or west 00000. So let's say if a point is over here on Earth, it would be 45 north, and let's assume this is about 60 degrees towards the east. So 60 east. So this would be written as north 4500 and east 06000. So that would become the latitude and longitude of that point on Earth. So using all this, we can navigate from place A to place B anywhere on Earth using its latitude and longitude. This is basically a complex representation of the simple Cartesian system on 2D to a 3D angular measurement which we use in general navigation. Thank you for watching.